Hello and welcome to our week 2 lesson. Okay, this will also describe the assignments that you have to do this week on pretty much spring break. So make sure you pay attention to everything. There will be some slides where I ask you some questions that I want you to respond on, like a Word document or a PDF after you do it, if you do it on Google Docs, to show that you actually watch this. So let's get started. Okay, so your assignments for this week. We talked about them a little bit, but you're going to do the literature and math lesson, which means you have to find a book that has something math related in it that you might do a lesson about it with. Okay, again, it could be a specific topic, or it could be just something fun and cutesy that you might read to kids and have them think about math in a different way. Remember, what you have to do with that is create a screencast of a type of lesson you would make. Please make sure that you highlight the book. I see a picture of the book somewhere on your screencast, or submit a picture of the book so I could see it on Brightspace along with your screencast. Now remember, a screencast is pretty much like what I'm doing here. I'm creating a lesson, I'm recording it, I'm using my voice, even my picture, so please make sure you do something like that. If you need assistance, I'm around all week till Thursday, so I can help you out at any point with it and give you a lot of ideas on how to approach it. Then you need to create 5 math word problems. Okay, they could be on any particular topic, but you also have to provide the solutions to it. Partly because we're going to be doing it next week with our students in the class. Remember, we're going to be on campus, so I want to make sure that you guys have those all ready to go. So that way, when we do that, we do some analysis and then we go from there. Then you got your discussion board posts and responses. You got a couple questions I've asked you. Make sure you answer them and then respond to a couple other people. And last but not least, you're providing video answers to the questions I've put here in this lesson itself. Now, keep in mind, some of the questions will actually show up on the screen. Other questions I'm going to say. So that's why I want you to watch this. Okay. One of the things I wanted to show you first was the math word problems, an example word problem. Let me see if I can do this. Can I move it up? I don't think I can move it up. But think about a word problem like this. Civil rights in the 1960s, court case Swain versus Alabama in 1965. The prosecution alleged there was discrimination against black people in grand jury selection. Census data from the time indicates that 25% of people eligible for grand jury service were black. A random sample of 1,050 people called to appear for possible jury duty contained 177 black people. Is there evidence of discrimination, especially in the legal process? Okay, so what this is an example from one of my stats classes. Okay, so again, you don't have to go that high. I'm thinking elementary, I'm thinking maybe junior high at best. So this is just a little bit higher, but this is the problem. So you would submit a problem like this, but you also have to submit your solution. You do not have to do a video solution, just put it on paper, however you want to do it, your solution to the problem. So that way when we do it, you'll have your answer key to see if people answered it correctly. In this case, what we do in stats is we come up with a null hypothesis. So we assume the status quo should be that 25% of the people who are black that are eligible for a grand jury service should be picked. Okay? And then you have HA. Well, we think the alternative is that something's happening. There's some discrimination and that it's actually less than 25% of people not allowing people to serve on the grand jury that were African American. Well, we know that our sample results, in this case 177 out of 1,050, is 0.17. So 17% were called to appear that were actually black. So, and this was an actual court case in the Supreme Court because, the civil rights era and understanding that African Americans did not get the same representation, especially in the court system. But in stats, we have a statistical process that allows us to go through this. So my students would complete something like this. They have to basically fill out this this formula. They have the information now. And then what they would do is they punch in the numbers, and what we would do is then make a determination. And I know it might be hard to see because my face is right here, and it's right doing that. Let's see if I can change it. No, I wish it would let me change where the video is. But we would come up with what's called a z-score. we'd find a percentage, and then we'd say, wait a minute here, statistically, this does not make sense. In my class, we would describe, what does that mean, statistically? And then we talk about what are the implications, how would we use this, why is this important? Okay, so that's why math word problems are so incredibly rich, because they can foster discussions, as we're going to be talking about later in this lesson. I just wanted to show you a little something here. Okay, so let's look at chapter 2, exploring what it means to know and do mathematics. Okay, so doing mathematics, really down to its nitty-gritty, involves generating and applying strategies to solve a problem and then checking to see if the answer makes sense. Okay, a lot of times we think math as just doing adding, subtracting, multiplying, dividing. And yes, there is that. But really, mathematics is taking all of the steps that we've learned throughout time and applying them to problems and seeing if we could find really good solutions. Okay, and I'm not saying good in terms of like for the environment or anything. Good solutions that make sense in terms of the context of the problem. Now, these verbs should be a main focus on any math lesson with students. You should be asking students to analyze, apply, compare, connect, construct, critique, describe, design, develop, explain, explore, formulate, generalize, investigate, justify, model, predict, represent, solve, use, and verify. Now, I don't expect you to do that on every single lesson. I just expect that at some point you have to do these verbs because you want students to do these things. Okay? Now, if you notice there, it's not calculate. It's not use a calculator. It's not find an answer. These are specific things to get kids thinking deeper about the mathematics. Now, part of being a teacher is providing worthwhile tasks. Okay? I can tell you, even as a teacher and as a student of mathematics, sometimes you don't get a worthwhile task. It's kind of boring. And that's the one thing you want to try to avoid. Can't guarantee it will always be that way, but you want to, at the most, provide something that's worthwhile. Why do the kids need to do this? Okay? So when you're designing tasks for students, you want them to do these things. They should be exploring. Okay? Exploring the problem. What's going on? Use strategies in order to figure out what they need to do. Okay? Again, just like what we do in everyday life. We do these things, okay? If we're given a problem, we got to explore, okay, what can we do? Where can I find things? That's where the strategies come in. Do I need to go on YouTube and watch a video? That's a strategy, and that's not a bad thing for students to have to do. But you want to do something where they have to think differently. Not just like, oh, I can get the answer in 5 seconds. Something where they have to really put some thought into it. And it should be something that extends their learning. Now, consider this task. And this is something I want you to write down, so hopefully you're paying attention. Start with 3, and then jump by 5s. So that means you start with 3, then you go 5 more, then you go 5 more. Write down the first 10 numbers you come up with. Do that on a piece of paper, and then you can type it into the document later. Now, when you've done those 10 numbers, do you see a pattern? Explain that pattern. It could be about evens and odds. It could be about, how numbers are moving. Is there anything that you see that happens regularly? So I want you to describe it. Just one quick sentence on the thing that when you submit this. What pattern did you see with this? And that if I were to use a strategy, it would be like, okay, I got to add. I've got to think about what I'm doing. And then if I wanted to extend it, it's like, well, what if we tried it with a different number? Would that change the pattern? So you can get kids to start doing things, because they should be able to, depending on the grade level, start with 3, jump by 5s. They should be able to see what pattern's there. And then if you change it, it's like, okay, does the pattern truly change if you change the starting number, or if you jump by 4s or by 6s? So that's definitely something that you want to consider. Especially when we're talking about giving tasks to students, we want them to think. It's not just a matter of doing, but thinking about why they are doing it is so incredibly important. But make sure you answer that and submit that with the other questions that I'm going to provide in just a little bit. So what does it mean to know mathematics? Okay, as a student, what do we want them to know? Okay, we know that procedural knowledge refers to knowing how to complete an algorithm or procedure. Okay, I would wager that all of us growing up, we focused a lot on procedural knowledge. Can I add two numbers? Can I multiply two numbers? Divide? Can I do and solve, say, like equations? Subtract on both sides, divide or multiply on both sides to get an answer. That's procedural knowledge. And that's important in mathematics. You got to know the procedures in order to solve problems. But really what we want to get down to is conceptual knowledge. We want to connect why we are learning it. Why is it important to learn the steps on solving an equation? Because how is that going to help us and connect later on? And so that's why that conceptual knowledge is where we want to really put our primary focus on. Procedural knowledge is important. Please do not assume that that's not important. It's just, procedural knowledge is just procedures. You know, that's just something that we should be able to do no matter what. We want to take that and then bring it to the concepts. Now, understanding mathematics is always going to be hard to define. You know, how do we measure how someone understands mathematics? Well, we should be able to, one, measure the quality and quantity of connections that an idea has with existing ideas. I mean, that's how we understand concepts outside of math. How do we understand how to write a sentence? Okay, it's the quality and quantity of those connections that we made with verbs, nouns, adjectives, you know, and grammar, which would be a lot of our procedural knowledge, to formulate the concept of writing a sentence. Well, it's the same thing in mathematics. Now, part of that is relational understanding. And you need to know in mathematics what to do and why you do it. Okay, very, very important. Because if a student knows what to do and why, they've built that relationship of understanding the procedure and the concept together. Now, instrumental understanding is doing something without it. Sometimes we do things in our everyday lives that we just do. We may not understand it, but we just do it. We don't even think about it. It's kind of in the back of our mind. It's just, you know, even sometimes when we drive, we don't even realize we went through a number of green lights. You do it. You don't understand it at that moment. It's just an instrument, but you understand why you did it, because now when you kind of wake up, it's like, hey, I know why I did it, what I had to do, why I need to make sure it's not a red light before I cross it, and so forth. And that's the same way in mathematics. We want them to know what to do and why, not just do something just because. Tools and manipulatives such as calculators, you can get counting, beads or dice, everything. Any of those tools that you could see in a classroom, they are important, and they can support it, the relational understanding, but they have to be used effectively. If you just use a tool to use a tool, that's instrumental understanding. Just showing us steps on how to do it on the calculator doesn't really tell a student why it's important. It just tells them, okay, how I can get the answer. So understand the difference between the two. It's okay to use tools. In fact, I will encourage you to use tools, but make sure you use them effectively. And understanding comes when students can build connections with ideas. Okay. Now, the thing you have to remember is that each student is unique. And so they may make different connections with different representations. Some people are more visual. Some people hear, and that's how they make the connections. Some people have to touch. And some people have to, do different things, maybe a combination of those things. As a teacher of mathematics, you want to encourage all of that. You want to find where are your students learning the best and encourage them to keep doing it that way. And when you have students who are maybe struggling, finding out what different ways can you change it to where they will understand it, and encourage them to use those methods. Because remember, when we talk about problem solving, there's not always just one way to solve a problem, but maybe multiple ways to look at it. And that's the whole concept of teaching mathematics right there. Now, mathematical proficiency. Proficiency isn't only knowing the list of the content from your grade. And that's including for students. But as teachers, it's not just knowing it. It's being able to demonstrate the practice as it applies to that content. So all the practices you want kids to do, it should demonstrate that they actually know it. And they're proficient in different ways of showing it. You'll see this right here. There are different strands of proficiency. Okay, we have procedural fluency, which is making sure you can do the procedures right. There's a conceptual understanding. That's part of proficiency. You should be able to comprehend the concepts of mathematics, operations, and relations all in one. Strategic competence is something important too. How you use what you have learned previously to apply it here. So apply the formulas, apply the representations, solve the mathematical problem strategically. Adaptive reasoning, capacity for logical thought, reflection, exploration, justification. How do you get kids to look past just like, hey, this is a problem, and why they can be adaptive and look at it from different lenses? And then, of course, you got productive disposition. Okay, that's where you can make sense of it. Why does it make sense to you? How do you internalize it, and why is that important? Okay, why is it worthwhile? And again, that does not mean that any one of these, 5 is greater than the other, but they're all intertwined because they all relate to each other. So here's my question for you for the document. When you learn math in school, growing up, think back. What focus of these 5 focuses did it look most like to you? Okay, was it more procedural? Was it more conceptual, strategic, adaptive, productive? And again, there's no wrong answer here. Everybody has a different way of looking at it. For me, I felt, my mathematics learning growing up, and again, I'm a Gen X kid, so it was more procedural. We did a lot of drill and kill, but that fluency helped me become more proficient because then I could spend more time on the other things. But that one, to me, just really helped me a lot. Being able to do those time tests and do them accurately gave me the confidence that I can go deeper. So again, for you, that might be something different, but think about your math learning. What did it really resonate with you? And believe it or not, what resonates with you tends to go towards where you're going to focus in your teaching. And that's not a bad thing, but you can't forget about the other things. Okay, really important. So the implications for teaching mathematics come down to this. So as a teacher of mathematics, you should focus on these things. You should always focus on building new knowledge from prior knowledge. Okay, you want that connection. Why are we doing addition? How does it apply to subtraction? How does addition apply to multiplication? Why is that important? Because you want to build it. Just like you want to build a foundation for a house, in order to go up, you got to build that foundation for mathematics and keep it going. You want to provide opportunities to communicate about mathematics. We'll talk about that in a little bit. But communication is important. Create opportunities for reflective thought. You want students and you yourself as a mathematician to reflect on why you're doing what you're doing. And why is it important? And that's the same thing we should have students do. You should encourage students to look at multiple ways of approaching problems. Again, there's a lot of problems where there's not one set way. Sometimes there is, but sometimes we can make it open-ended, much like our state tests, where we want to see what they're thinking more than the answer. You want to engage students in productive struggle. You want students to understand it's okay to not get the answer in 2 seconds. You want them to think about it. You want them to ruminate on it. You want them to really understand why this is important, but you have to understand that kids will struggle, and it's okay to struggle. I think sometimes we think mathematics, if you don't get the right answer right away, you're not a good math person, and that's not true. Sometimes, the longer it takes, sometimes it seeps in even better. You want to treat errors as an opportunity for learning. Okay, we're going to make mistakes in mathematics. You want to encourage them like, hey, if you make a mistake, it's not the end of the world. In fact, it may be the best thing for you to realize that, hey, we have to look within ourselves as students, even as teachers, and realize, hey, we learn more from our errors than we actually do sometimes from our successes. And then we want to scaffold new content. That comes with the language that we talked about last week. How do you deal with English learners? Scaffolding the content, making sure that you're not going from here and jumping way up here without giving them basically a ladder. And then you want to honor the diversity of your class, because you're in a class with a number of students. That diversity is important. Each student's going to think differently, reason differently, talk differently. Let's honor that, because it doesn't mean that they are less valued than others. So we look at chapter 3. So that was chapter 2. We're looking at chapter 3. Teaching through problem solving. So mathematics has changed quite a bit. Well, not in terms of the math itself, but the way that we approach teaching students. So teaching for problem solving. So there's two different ways that you can look at it. Teaching for problem solving starts with learning the abstract concept and then moving to solving problems as a way to apply the learned skills. So a lot of times you'll explain the concept, why it's important, you'll practice it, and then the problem solving comes with those questions after that. It's not a bad approach. Again, most times we have learned, we have to learn the basics. So if I'm learning, how to use a specific tool for woodworking, I've done some woodworking myself, I need to learn how to use that tool first, why it's important, practice using it, and then I can apply it to the problem. Okay? So again, this is a traditional method of learning, and it's not a bad way. Okay? Again, I'm not saying any bad ways, I'm just saying there are multiple ways that you can approach things. Teaching about problem solving. That's something that's sometimes missed. You have to give guidance to students on how to problem solve. Okay? Students don't know intuitively how to solve problems. They look to the teacher to give them guidance, and that's where it is a big focus. You have to teach them how to problem solve and how to approach things. So that might mean looking at specific numbers or looking at specific words. You have to teach them that. It's important. They will not know automatically, oh, this is what I have to do. So there's got to be some guidance there. The 4-step problem-solving process that I would say is that students would have to understand the problem. So you give them a problem, they have to be able to understand what they're reading. Okay? So obviously, first graders, you're going to scaffold a lot more than maybe you might do with 6th graders. Okay? They may be able to read it automatically. But they both have to understand the problem that they're looking at. Then they have to be able to devise a plan. Whether it's in their mind or on paper, what do you have to do to get it done? Okay, so they have to plan. Okay, now some people will instinctively know what to do like that. A lot of people may have to write down some ideas. Okay, brainstorm. Once you find that plan and that you want to approach it that way, carry it out. Okay, that means getting an answer. But at the same time, once you carry out that plan, that last step, you have to look back. Did what you get make sense? And I think this is one of those areas where a lot of students tend to forget, and we have to encourage it as teachers. Kids are more apt in mathematics to just try to get the answer and be done. But they don't know if it's right. Does the answer make sense in the context of the problem? And that's where we have to encourage them, like, okay, summarize it. Does that make sense with what we're working with? So if we're talking about, area, and you get something that's a wild answer, whether it's either too high or too small, does that make sense? And you want students to reflect back, did that answer work? Because if it doesn't work, then maybe there's a different problem with our plan and how we carried it out. Some problem-solving strategies that you have to look at. You want to encourage kids to do these things. You want them to visualize what they are reading in their minds or on paper. You want them to look for patterns. Many mathematical practices involve patterns. That's how we find solutions. We find a pattern, we create a rule, and we know what's going on. They should be able to predict and check for reasonableness. I had to drink something. They should be able to formulate conjectures and justify claims. They should be able to create a list, table, or chart to help them with this. Simplify, it should say simplify or change the problem to help them out. Or write an equation. All of these are valid. It doesn't mean you're going to use all of them in each problem, but you should encourage students to look at different ways of approaching it. Because some kids can easily write an equation and boom, they're done. Other kids have to visualize or look for patterns or try a few things out. Some of them have to be like, how are we going to do this? Okay, if I do this and then can I justify it later on? Does it make sense? Again, multiple ways for students to look at problem solving. Now, teaching through problem solving. Okay, so this is a little bit different. So the way that I kind of described it before was like, hey, we are going to do the content, we're going to practice the content, and now we're going to apply it with problem solving. Teaching through problem solving means that students are learning mathematics through inquiry. This is a little bit different. This is kind of where mathematics teaching is kind of moved towards, although it's really tough because a lot of us learn the other method, teaching for problem solving. Teaching through problem solving takes a little bit more practice. This is where you explore real context, problems, situations, models, and from those explorations, you learn the mathematics to go behind it. So a lot of times you will see in a unit, they will give you a unit problem. You won't be able to solve it right away because you haven't learned the content. But you have the problem which you're basing everything that you're going to learn on. So you want to get to solving that problem by learning then the content, but you're given the problem first. Okay? So teaching through problem solving might be described as an upside down from teaching for problem solving. So you're given the end task first and you're working backwards kind of. Whereas teaching for problem solving means, hey, you're given the lesson, you're given the task, and then at the end you're actually doing the problem solving. So it's a little bit different in those respects. What this does, this type of teaching, and it's tough to do. I'm not saying it's the easiest thing for teachers to do, even for myself, even as practiced as I am. But what it does for students is that it gets them to ask questions. It gets them to determine solution paths. And when I say paths, sometimes students find one way of solving it. Some people solve another way. It's okay. The solution paths don't have to all be the same. You want them to use mathematical tools, so they start figuring out what tools are going to help me out. They're going to make conjectures. They're going to try to find patterns. They're going to communicate the findings with each other as student to student or even student to teacher conversations. Problem solving does make connections to other types of content and context, especially if it's cross-curricular. Allows them to make generalizations, and then it helps them reflect on results because does it make sense in what they got? Okay, so all of these things are important. Now, teaching through problem solving does help students become more mathematically proficient. Okay, it focuses the student attention on ideas and sense making. Okay, so again, students have to make sense of this. They have to provide their ideas. So it helps them get a laser focus on like, what is it? Why is it important? It develops mathematical practices and processes. So they realize what practices and processes do we need to get this done. Okay, gives them confidence and really builds their identity as a mathematician. Okay, they have to really think. If you're encouraging them to do this, they have to think. It's not just something they can get the answer and they're done. They've got to think about how they're approaching things. It builds on the strengths that they bring into your classroom, the funds of knowledge that we encourage them to have. It allows for extensions and elaborations, especially if you got some kids that are able to understand how to get it. Could they apply it in an extension? Can they elaborate a little bit more using their creativity? It engages students. If they have to think and they're talking and they're working with each other and they're really having that great mathematical discourse, you don't have discipline problems because they're talking and they're talking academically, which is important. Okay, doesn't always happen perfectly. Again, this comes down to us as a teacher facilitating that, but it does help when they're engaged. They're not going to be a discipline problem. If they're disengaged and they don't care, yeah, they're going to lash out or do things and have actions that you don't like. It's going to provide formative assessment data, and that's going to be a key thing going on later on in this lesson. And then it invites that creativity that I described before. Creativity for our kid, especially if they can connect what they are good at. Maybe it's art, maybe it's writing, maybe it's a song, and you encourage them to be creative in that. With mathematics, they're more apt to do the mathematics. Now, tasks that promote problem solving. Worthwhile tasks are those that do not have a specific prescribed approach. Okay? If it's a problem where they have to do one method, kind of like what I gave you guys, that statistical problem, it has a prescribed approach. You need to do this to get the answer. Okay? really good problems are going to allow them to look at it from multiple different avenues. Okay, so again, I gave you guys pretty much, it's a worthwhile task for my class, but if we're talking about deep problem solving, it's not the best one. Okay, and again, sometimes you're going to give problem solving tasks that are not deep. Sometimes you need to give tasks that are deep because you want them to go further. Okay, so keep in mind the difference. Doesn't mean that what I gave was bad. It just means that it's not fitting exactly this. Other features of worthwhile problem-solving tasks should be high-level cognitive demand on the student. They got to be thinking. If they're not thinking, it's not really worthwhile. They should be able to approach it from multiple, what we call entry and exit points. How they look at it one way, some students might look at it a different way, and then the way they get their answers to get the exit out of the problem could be different, and that's okay. It's okay to have multiple ways of looking at it. It should be relevant in terms of the context. It should be something that they can relate to. If you're giving them something that just doesn't make sense to them, especially when we're dealing with like English learners and those that have special needs, you want to make sure that they can really get into the problem and why it's important to understand the problem. And then it should, if you can, and these are tough, and again, this is tough. This is not something you're going to be able to do right away. A lot of times you're going to need to get some help with this. Is connect it with, language arts. Connect it with history. Connect it with science. Connect it with other disciplines. That cross-discipline nature can make it so important, because why is it important to learn the science? Well, mathematics and science go hand in hand. Why are they important with each other? Just because you write an essay or write sentences doesn't mean that's not related to math, and why that's important to explain your thoughts, your ideas, and your conclusions. Now, what about drill and practice, or for a lot of us that are older, drill and kill? Okay. Now, practice refers to varied tasks or experiences focused on a particular concept or procedure. You should practice things with your students. Very, very important. Okay, you should practice it, but you can over practice. Much like a sports team, you can over practice and overdo it to the point where it doesn't have the same meaning. So you have to be very careful with it. Now, drill. Repetitive exercises designed to replicate a procedure or algorithm. So you remember those timed, if you remember, if you didn't, the timed adding, subtracting, multiplication, and dividing tests. You might have had 100 questions. You might have had 1 minute, 2 minutes, 5 minutes. Those are repetitive exercises, and I'm going to tell you honestly, they are not horrible. But the problem is, if that's your main focus in mathematics, that is horrible. Okay, because just learning that isn't the most important thing. Do I think that there's a place for it? Yes. I honestly think that drills such as adding, subtracting, multiplying, and dividing, especially those time tests, those math fluency skills, the numeric fluency skills, are essential. Because we find, especially at the high school level and even the college level, that when they are missing those things, guess what? It takes them longer to really get that problem done. We don't want that to be the case. We want them to be able to take the concept and do it. But we don't want them to be like, oh, they got the concept, but then they're having a problem with the mathematics, the fluency behind it, the procedures, to the point where they get frustrated and they check out. Okay? So very, very important. Do I think that there's a place for it? Having coached basketball and baseball, we did drills such as free throws every day. In baseball, we did our throwing every day a specific way. Are they important? Yes. Is that the main focus of why we played baseball or basketball? No. They have a place, but it's not what it's all about. So you have to be very careful with that. If the kids don't get it, you can keep going, bring it back, every so often. It could be one of those little extensions like, hey, we got a quick 10 minutes. Hey, let's do one of these and, make it fun. Okay? Don't make it anxious for the kids. Always keep drills short, connected to the related content. If you're doing the mathematics, if you're doing like the adding, time tests, why is that important to what you're learning? I mean, it's important to learn in addition. It's important to know our math facts. Don't get me wrong, because that helps us later on. But if it doesn't help with what else we're learning, it's just kind of that one-off. It's like, okay, why did we do it? And for a lot of kids, they need to know the why. So here's my next question for you. Okay, so again, this is something, make sure you're paying attention. Do you remember a problem or project that you really enjoyed growing up because it was different than just, say, drill and kill? Do you remember any of that? You know, for me, because I'm a geometry teacher, I teach mathematics, I got into it. I loved a project, and I've used it even with my own students, where we had to measure the surface area of a building. So we took the concept of surface area that we learned in class, and we applied it to a big scale of a building. Now, growing up as a freshman in high school, I had a teacher, Andy Cantrell. He's now retired, but he got us to go, as a GATE student, we had to measure, at least I was in a group of, I think there was 3 or 4 of us, we had to measure the Superior Court building down off of Chester and Truxton. And that building is not an easy building because it's got little crooks, nannies, different heights at different spots. But it forced us to really think about what are we measuring and how are we measuring and why we have to be precise. Okay? To me, that was a perfect application assignment from why we learned it. So I took that, learning it from as a kid, and I applied it to my students, where we do one on our campus. I taught at East High, so we had a number of different buildings, and I had them do it. And I go out and help them. That's the thing. You want to keep these, type of really deep problems. You have to be there to scaffold and help when necessary. And so I would do that. And so for a lot of my kids, it's either take a final exam or do this project, and they love the project because it really got them deeper into the math and why it's important. And so that to me is one problem or project that I felt just really resonated with me compared to just learning about the concepts. So again, tell me something that might have resonated with you, something you remember, maybe a teacher in the way that they did things and how they got you to really maybe enjoy that math. Doesn't mean you enjoyed all math, don't get me wrong, I understand that. But if you want to be that teacher for mathematics, you got to think about ways that you could do it the way that really engaged you. Or if you have your own kids, what engages them? Okay, so think about that, write that in the document, make sure you submit that. There's a couple more questions coming up, so make sure you're paying attention. Orchestrating classroom discourse. Okay, so if you give kids problems to solve, they got to talk. Okay, important. The value of student talk is so important. I know we think about classrooms and they need to be quiet. Kids have to be learning, taking it in. But the problem is, most students can't just take it in. They need to talk about why it's important. And actual student conversations with each other are probably more powerful than anything else because students have a way of talking with other students and getting those ideas across. And I need, as a potential teacher, looking at teaching mathematics, encourage them to talk. Some of my best lessons are where they're doing the talking and I'm basically just being quiet and letting them talk. Part of my my second master's thesis is that I used technology to see if that was going to help with the learning compared to just doing a regular lecture. And what I was finding in these lessons, the kids were just yelling at each other back and forth. This is the answer. No, that's why the answer is right. I'm just sitting there. I'm being a facilitator. I'm letting them do all the work. And that's what you want. You want them to talk. Okay? You want them to talk with each other and work things out. They are naturally, and some they'll come talk to you. But when they talk student to student, that is the best thing. Again, going back to my geometry class my freshman year, I had my friend. His name was Mike Smith. Generic name, but he lived in Rosedale. He went to East High for his freshman year, then went to Centennial. But our freshman year, we were in the same class. He was struggling with a little bit, and we were on the phone. This is before smartphones and everything, and we would discuss our homework. And I would discuss the ways that I was looking at solving it so he could do it. And it was helping me learn the material more so I could teach it to another student. So you want that. So like English learners, you want them to use the language as much as possible. You want all students to use the language so that they understand why it's important. Okay? So make sure that you are orchestrating that. Biggest things that you can do as a teacher to help with that. You have to anticipate the questions students are going to have questions on. Where are they going to struggle? You have to monitor. That means walking around, talking with the students, making sure, where are they having some misconceptions at? Selecting the tasks appropriately for the students. Okay? Some tasks you have to really scaffold and lay out, what they need to do. Other tasks you can, let them go and they'll be fine. But that's part of learning your students. Sequencing, where does it fall within a unit? Where does it fall in terms of their learning? And then having them make the connections and connecting it with them, helping it for them, but also allowing them to really be, the advocate for their own learning. Okay, but that's actions that we have to take as teachers. So when we get to now, chapter 4, creating assessments for learning. Okay, I think it's actually chapter 5. That might be my bad right there. 3 important assessment ideas. Okay, when we talk about assessment, that means figuring out what the students have learned. Okay, assessment should always enhance the student learning. It should never break a student down. Okay, you need to know what they're learning. Okay, it's so incredibly important. Please, I cannot overemphasize this. It should also be a tool to make the instructional decisions. Okay, if you're not looking at how the students are doing on the test and then adjusting how you do instruction, that's a problem. Okay, and then you should give feedback to the students. You have to give them feedback. It's not just a grade on a test. It's not just a score, but you got to give them feedback on what they're doing right and what they might not be doing right, and using that to help guide them to get it right. Okay, stop and if you've always thought about assessments as a test and a score and a grade, try to get away from that. We still have to give grades, we still have to give scores, but you want to make assessments worthwhile to the students so you can give them the data that they need and the feedback they need to make themselves better. And it also helps us as teachers. If I didn't teach something right, guess what? I need to go back and either reteach it a different way, not louder and slower, but teach it a different way, approach it from a different lens, because maybe what I thought was going to work didn't. That's us teachers. We have to reflect on our practice. So an assessment isn't just about how well the kids did, but how well I did as a teacher. I can speak from my own experience this last week. I gave a test on polynomials to my advanced algebra students, and they really struggled with the test. But I think I made the mistake. I didn't practice on certain things enough that I know now when we get back from spring break, at least at my school, I can go over those things a little bit more to make sure they get that down, because I know they're capable of it. I just think that the crazy week before spring break probably wasn't the best way of approaching it and getting things done. And I was gone one day because of a meeting, and I think that really affected the students, but that's me reflecting in practice. Their grades should not reflect my inability to get them to do it right. Okay, so you have to think of it that way too. You'll hear these phrases come up, and this comes up in every discipline. Now, notice I'm not really saying anything about math necessarily. When we talk about assessment, there's assessment of learning, and there's assessment for learning. Okay? Assessment of learning refers to summative assessments. What have the students learned? Okay, so think about a test that you've had in the class. Teacher gives that to you because they need to know what you have learned. Okay. Now, an assessment for learning, and we talk about summative assessments. Summative assessments are after the fact. Okay, if you've learned it, you've done well on it. If you haven't learned it, you haven't done well. And a lot of times, it's at the end. And if it's at the end, it's kind of like an autopsy. You're dead. So either it was a good death or it was a bad death. Okay, but you can't really change it. assessment for learning refers to formative assessments. Okay, so that's like going to the doctor before you die, getting checked out, making sure you're meeting certain goals, so that way you can live longer and healthier. Well, it's the same way in academics, and especially teaching mathematics. You should be using formative assessments a lot because you need to see where the students are. And you need to catch them before you get to that summative assessment, before it really affects their grade, before they feel, I can't do it. Because a lot of times, it's just like a little thing that you have to, explain differently, and they get it. It's a misconception most of the time. It's not a whole, like, I don't know anything. Okay, in mathematics, that's the way it is. Even my own stepson, he was doing geometry. I made the class, with the other teachers. And I just had to explain one thing a little bit differently, and he was able to complete the assignment. I didn't have to teach him everything. So again, the formative assessment tells me, what do they know now? Where are their problem areas? And what can I do to fix those problem areas before they get to the summative assessment? So this leads me to another question that I have for you. And again, this will be written down in your stuff. When you've heard the term, and maybe you have and maybe you haven't. If you haven't heard it, just tell me you haven't heard the term. If you heard the term Common Formative Assessment, or CFA, what does that mean to you? What does that mean to you? Give you a chance to think about that. Hopefully you're watching this, of course, while I take a drink. So what does Common Formative Assessment mean? So I'll let you ruminate on it. I might discuss it a little bit more in just a little bit. But again, put that in there so that way you have a number of questions that I've already asked you. That tells me you've watched the video, but we're not done yet. So keep tuned. Okay, so what should be assessed? Okay, that's really important. You should assess their conceptual understanding and procedural fluency. Okay, can they solve the problem procedurally? Do they understand the concept? You got to assess that. That doesn't necessarily happen at the same time, though. It can happen at the same time, but it could also happen at different points during the entire process of learning. You should assess their competence and their adaptive reasoning. So did they adapt to the changes in a problem? Did they adapt to the thinking of the problem? Are they competent enough in the concept that they could give you good answers? Okay. Again, this applies to every discipline. My doctoral dissertation was on formative assessment. Why formative assessment is so important, because you can do these things without even the kids knowing. And that's important too. You should be able to assess their productive disposition. And again, some of these things, when I say assess, does not mean you're giving them a grade. You should be observing them to seeing where they are at. If they're being productive and they are liking it, you'll be able to see that on their face and in their work. If they are struggling and they are starting to get anxious, you should also be able to see that and be able to provide that extra assistance. Okay? So it's not a matter of just, hey, I give them a task, I sit down and do something else. No, you got to make sure you're always assessing. Formative assessment is so crucial to learning that you need to be doing it maybe even more than the summative assessment, because you're going to learn a lot more about your kids and about where they're at mathematically by formative assessment than you will summative assessment. Assessment methods can include different things. Okay, it's not just answers on a test, but it can be. Don't tell me it's not. But you should be able to observe them. You should be able to walk around, and I tell some of my new teachers, walk around and record who's on task and everything like that. Because if you got a bunch of people not on task, was the task too easy? Was the task too hard? Is it something where it's done and you can move on? You should always be looking at gathering data and like, how are your kids doing? And specifically, what kids? Because you may have little Johnny in one area of the classroom, he's distracted by other people. Move him to another part of the classroom and he'd be perfectly fine. But that's part of formative assessment. making sure that you give them that opportunity to have the conceptual understanding and procedural fluency, competence in adaptive reasoning, productive disposition. Okay, so that's observation. Okay, questions. The questions you ask are important too. You have to ask the right questions, and that's where you have to learn your questioning techniques. Okay, a lot of times, and my kids don't like it, but that's just because it's a generational thing. I answer their question with a question. Does that make sense? Or does that seem right to you? Or did you check your notes? And I'm dealing with high school students, but I want to question them. I don't want to just give them the answer, but I want to lead them to the answer. Okay? There's a difference between the two. I can answer it for them, but what does that solve? But I can lead them to that thinking, that thought, and then they're like, oh, okay. And I haven't given them anything. I just force them to think. Okay, so you want to assess, okay, I can change the wording of my question to give them the answer without them realizing. So really, questioning techniques are going to be important. I definitely would encourage you to look within the chapter on the different types of ways that you ask questions. Interviews with students are important. Yeah, we ask questions of students, but talk to a student and see how they're feeling. Get an idea of how the class is feeling by asking and interviewing couples' kids and saying, okay, what are you struggling with? What help do you need? What makes sense to you? What doesn't make sense to you? Maybe you can talk to your student that's getting everything done, and then you're realizing they're not getting it done. Hey, what's going on? Where is the little it that's keeping everybody from being there? And that type of stuff is so important because that drives your instruction. It drives how you relate to the kids. And if they feel that they can share with you what's going on without prejudice, without judgment, guess what? They're going to be more willing to go further. Okay? And again, these are things that you could do in any subject. So if you're an elementary school teacher, do this all the time with anything. It's not just math, all the time. And then the tasks. Okay? Did they complete the task? Did they get part of the task done? Did they get some of it done? Because again, just because they may not have got the final answer doesn't mean that they didn't do anything worthwhile. Okay, so you have to keep in mind, it's not always the answer. In fact, our state CASP tests, some of the performance tasks are more about what they are thinking than they are about the answer they finally get. It's really not about the right answer. It's about, can they think mathematically? Can they strategize? Can they formulate a plan? Can they at least attempt to do something? Does it make sense? And even if it's wrong, it's better that they're doing that than just getting an answer. Now, one way that you could look at it is through a rubric. Again, if you don't know what a rubric is, it's scale-based. The idea is that it tells students how they can do well on something, but also providing you as a teacher a way of scoring them, so that way they can see where they made a mistake, but also where they're at in terms of their learning. This is an example of a 4-point rubric. It doesn't mean you have to use it, but it's just something you could. You're going to have areas where kids fall within a area. It's not always that they got it or they don't got it, but they may be in different shades depending on what you're asking them to do. Very much so for those that are, had gone through school, especially in the 2000s, when we did CST testing, there was advanced, proficient, basic, below basic, far below basic, because some kids, are good at some things and bad at others. And so they fall within, a spectrum. Okay, that's not a bad thing. As a teacher, it's always good to show them, like, okay, you're good here, but you weren't good here. Oh, but you were really good right here, but you really struggled here. And then it helps us as teachers realize, okay, if I got a bunch of kids that are struggling on this one area, then I know I need to go back through it. I know, we do this in terms of data for our teams that we work with, our grade level teams, in this case my Algebra 2 team, is that I went through the test scores, which I knew were not the greatest, although some did really good. But they struggled on certain areas. Like they got most of it right, except for one little area, here or there. And that allows me to look back and say, okay, they did really good on the basic questions. They did good on the intermediate questions, but on the advanced questions, they might have been maybe more marginal or unsatisfactory. Maybe they didn't even start it. So then I can focus my instruction on those things that they didn't do well, not on the stuff they did well. If they all did well on certain things, why am I going to go back over it? I want to go back over the things they didn't to get them and raise up the bar. Okay? So that's part of why assessing is so important, especially formative assessment. Yes, I have to give them a grade, but then part of my job is not just to give them a grade, but then help them where they didn't do well. So that leads us to shaping instruction. Okay? For assessments to be useful, you need to act on the evidence given in an assessment, or any assessments that you do, whether that be formative or summative. You have to address the learning needs of all of your kids. Okay? So when you're thinking about your lesson plan for your chapter presentation, hey, remember those are coming up. Think about how will you assess them before you start, while you're doing a lesson, and after a lesson. Because if you wait till way after, it's too late. If you do it during the lesson and you can get that lesson done and they understand it all, that's one less thing you have to worry about, because then they will have that understanding. Because what happens is, and this unfortunately happens in teaching all the time, is that a lot of times we focus on covering topics. I got to cover all this before the state test. Problem is that just because you cover it doesn't mean the students understood it. Doesn't mean that. And because it doesn't mean that they understood it, it means that now that you have to go on to another topic and another topic and another topic, and sooner or later the kids have fallen behind. They may be able to do enough for a grade, but in terms of really truly understanding the tasks and the concepts, they don't. And so if you move on and they don't understand what happened, they accumulate what is called debts of knowledge. And what ends up happening is, as they go through elementary, they go through junior high, and they come to high school, and then even go to college, they're missing pieces of information. There's gaps in their knowledge. And those gaps, especially in high school, as I teach, those gaps become so important because we do expect them to know it, certain prerequisite concepts, but then when we teach it, we realize, oh, they don't know it. Doesn't mean you didn't teach it right. Doesn't mean that things were done bad. It just means that somehow, some way, something got lost, and it's like two ships passing in the night, and then we're having to reteach. And that happens in every grade level. It happens even in college, in some of my college courses that I've taught, where you think things that students should know, but they don't. And that's because something got lost in translation along the way. So as a teacher, it's our job to do the best job we can all the time. And it's tough. And especially when you're teaching multiple subjects, yes, it's even tougher. But being a teacher means we have to do that job.